Okay, so in this video, we'll be discussing our May-June, all right, 2004 paper 5-1 for statistics 1. So let's have a look for question number 1. Okay, they give us some summaries values for 20 values and also another 25 values of x. So this is the summary that we have. Okay, then they want us to find the mean of all the 45 values of the x. Okay, so first of all, maybe we need to recall back of how to find out the mean and also maybe the variance for all this coding method here. Okay, in general, if we want to calculate the mean, right, the general formula is mean equals to summation x minus a divided by n. Then have to add back the a. So for our case here, for our example here, all the values are minus 30. All the x are minus 30. So you can actually try to replace this by 30. And after that, I need to add back a 30. Okay, then because we are having two set of value here, 25 values and also 20 values, yeah. So to calculate the mean, basically we need to combine all the summation, okay, in the formula. So that means I'm having summation x minus 30. So to find out the answer for the whole set of data, I need to include this summation x minus 30 for both sets. So that means I'm having 439. Then also, how about the other 25 numbers value? So the summation x minus 30 for this one is 470. So you have to add them together first, then divided by the total n. So what's the total n here? So in total, I'm having 45 values. Okay, 20 plus 25, I get 45, and add back the 30. So this is a general formula, and this is how we apply in two sets of data where all of them are x minus 30. Okay, then after that, just use calculator and try to get the answer for this one. So by right, you should be having this as the final answer. Okay, right, so let's look for part number B. Yeah, so the same thing happened here. They want us to find the standard deviation for all the 45 values of x. Alright, so again, let us recall back the formula for standard deviation in general. So this is standard deviation. The general formula by using the coding method is x minus 30 squared divided by n. Okay, then minus summation of x minus 30 divided by n and square this whole term. Okay, so this is the general formula. Right, and because of, again, we are having two set of data now, right? So when you want to apply this formula, you have to include the values for both data to get the answer. So as an example, if I want to apply this in my question here, I need to include summation of x minus 30 squared for both sets. So I need to take 12405 plus 11346. Okay, so I add them together. 12405 then plus 11346 divided by the total number n, which is 45, minus summation of x minus 30 divided by n, then you square it. So same thing happens. So summation x minus 30 is these two, right? So add them together. Then divided by 45 and you square it. Okay, so if you don't do calendar mistake or whatsoever, by right you should be having this 527.8 minus 408.04. Okay, then you can further simplify it, and after that you should be getting a long number. Okay, so if I want to show it out, I'm getting this 10.94349122, and this is a long decimal number, and we should simplify it, become 3 significant figure answer. Yeah, so this is how we actually solve this question number 1. When we are having two set of data, to apply the formula, you have to add the summation of x minus 30 square for both sets. Same thing happened here. Right? Yeah, so this is how we solve question number 1. Alright, so question number 2. We are given the length of the tail of adult raccoons of a certain species are normally distributed. Okay, so I think you need to highlight the keyword normally distributed. Mean is this one, and standard deviation is 3.3. They want to find the probability that a randomly chosen adult has a tail length between 23 and also 35. Okay, so for this question, I think the keyword is very, very obvious where you can see the keyword normally distributed. So it is X normally distributed and having the mean 28, then the standard deviation is 3.3 and then square. Right, then we want to calculate the probability for the length is between 23 to 35. So I'm having 23 to 35. X is between 23 to 35. And since you know that X is normally distributed, right? So you have to standardize them. Standardize it because you can find out the area. Alright, so I'm having 23. How to standardize it? How to change it become Z? You have to minus the mean divided by standard deviation. So 3.3. Simply happen for the value 35, you have to standardize it. So you take 35 minus the mean divided by standard deviation. Alright, then you can try to simplify it. Then I'm having negative 1.515 and also 2.121. Alright, so to find out this particular probability here, if I try to visualize it from the diagram, okay, so I'm having actually negative 1.515 and also this value which is 2.121. And this is the particular area that I want to find. Okay, then according to this area, I want to write out my step. Okay, I want to write out my step so that I can find out the value that I want from the table. Okay, so what I want to do is like to find out this particular area, I want to find out this green color area first. So to write out this green color area in formula, right, in the step, in the symbol, it should be Z. I want to find the area Z smaller than 2.121. Okay, so this is whole green color area, but I only want to consider this shaded area as my final answer. Therefore, I need to minus this blue color area. I hope that you can see it. I want to minus this blue color area, the small one, so that eventually I get this shaded area here. So the small blue color area here is Z smaller than negative 1.515. Yeah, that only I focus on the table to find out this probability and find out this probability. Okay, so this is what I want to do. So basically, I get this formula from the diagram, from logic. All right. I want to mention a very common mistake that can be seen when my students trying this question. A lot of my students, right, when they look at this particular step, what are they going to do is like, they just simply make it become 2.121 and minus Z greater than negative 1.515. Because if they have a look for this sign here, when they write out in the proper way, it looks like this one. But basically, this is wrong. Okay, so if you try to get this one, very likely you'll get a positive answer. Answer more than one, which is definitely wrong. Yeah. So when you're having any area, okay, or Z which is between any two values, the standard method is it will be good if you can draw it out by using a diagram. Then you write out the step. So this is a common mistake. This is wrong, and I can see a lot of students are doing this, and this is only the correct method. Okay. And of course, if you want, you can also use 1, then minus these two areas that I don't want, also can. Alright, but if you directly look at the symbol and you directly write out the equation like this, it is definitely wrong. So you have to look at the diagram and write out the correct value here. Okay, alright, so just a small reminder. Yeah, right, then after that, you can find out the value from the table 2.121. So go to the normal distribution table, looking for 2.121. This is 2.1, 2 is here, then 1 is this one. So you need to have 9830 plus a 0. So in your step, you'll be having 0.9830. Okay, then minus, and how about this? So negative 1.515. Negative 1.515, right? The value negative will not be shown in the table. You can see that all my table values z are all positive. There's no negative. So what we need to do is we have to imagine this area is actually same as the probability of z greater 1.515. Okay, so this area and this area should be the same. The probability should be the same because they are symmetry, right? Then you should look for this value in the table to get the answer. But when you look at this value to get the answer, right, in the table, they give us the value for z smaller than 1.515. And therefore, you need to take 1 minus this answer from the table to get the answer that I want, which is this one or this one. Okay, so we're looking for 1.515. Okay, so 1.5, 1 is this one, and 5 is this. So you have to take 6, add the 6 to the last digit of 9365. So 9345 plus 6 at the last digit here, you'll be having 9351. Okay, then go back. So I'm having 1 minus 0.9351. Alright, so simplify this particular step. By right, you should be having 0.9181. And hence, the 3 significant answer should be 0.918. Okay, so this is basically how we solve this question. So the commonly seen error is this part. Alright, so please make sure that you don't do this kind of mistake in the exam. Okay, then let's continue to part B. Alright, so for part B, if you have a look here, again, highlight the keyword normally distributed. Then you are having the other mean and also standard deviation, unknown standard deviation. 75% of the adult raccoons has the mass greater than 7.6. Then find the value of sigma. Okay, then again, this one is another type of raccoon. So I maybe label it again. X is normally distributed, the mean is 8.5. Then I'm having sigma squared. Alright, so to find this sigma, basically you need some maybe one information to start with. So how can I get this extra information needed? You can get it from here, the last sentence. 75% means the probability of the adult raccoon of this species has mass greater than 7.6. So if you try to rearrange or rewrite this symbol in this sentence into the symbol word or symbol way, so you will be having x greater than 7.6, so more than, greater than 7.6. And what's the probability? It is 75%, so it will be equals to 0.75. Okay, then this is the x mark. Therefore, I need to change it become z before I can find out any value from the table, right? So I standardize it first. 7.6, I have to minus the mean. So minus 8.5 divided by standard deviation. So divided by sigma, that I don't know what's the value yet. Then equals to 0.75. Okay, and now I want to have a look for my diagram, how my diagram look like. So if you have a look here, z greater than a value equals to a big area. Any value more than 0.5, I will call it as a big area because it is more than half. Alright, so if let's say z greater than a number equals to 0.75, means that by right, your z should be somewhere here. And this area on the right hand side greater than, you can see the greater than, right? So the area should be on the right hand side of z, and it must be a big area. So this is the one. Alright, some students will ask, why it cannot be something like this? How about my z is here, then on the right hand side? This one cannot, because you can see this area is small. Cannot be more than half, 0.75 already more than half. Okay, so therefore this is the first one is the correct graph, the second one is the wrong graph for this particular question, right? Okay, then now I know that this area is 0.75. I want to know what's the value for the z. Okay, so I go to the table. The 0.75 is a probability. Therefore, if I want to look for the value, I need to look for probability and find out the value of z. So we are going to do it in the reverse way. That means I look at probability and to get the value of z. Just now in part 1 is we have the value of z, then we find in the probability, right? Yeah, so now it's a reverse, the opposite way in the reverse sequence. Okay, so let's have a look for 0.75. Is there any value close to 0.75 but smaller than it? Okay, so I think this one. This is the value smaller than 0.75 but closer to it. Okay, so 7,486. I need to add 14 to get 0.75. I need to add 14 as the last two digits, right? So is there any 14 here? No 14, but the closest value that I get is 13. Okay, the closest value that I can get is 13 here. Therefore, if you want to read out the probability, the value of z, it can be 0.6, then go up, it is a 7, and this value go up, it is a 4. So if you combine all the value together, it will be 0.674. Okay, so this is how we actually get the value for the z. We are doing it in reverse way, so from here, go up. Okay, but if let's say you are aware, sometimes you can use a shortcut table where you can scroll down to the bottom of the table, and then there are some values of z that we using it quite often one. It might be appear here. So like for this question, we are looking for 0.75, right? You can have a look. The probability, is there any 0.75? Yes. And they will list out or they will directly state the value of z for you. So you can say that, oh, my value of z is actually 0.674. So this is a shortcut, but of course, for this shortcut table, they didn't give you all the value that you want. So only certain probability will be given. So if you are aware, then you can directly use this formula, which is this table, which is much more convenient. Okay, so from here you can see the answer is 0.674. All right, so go back. All right, so I know that my z is equals to 0.674, but if you observe in the diagram here, this z is on the left of 0 because the center is 0, right? We know that for a normal curve, the mean is 0, so the center is 0. So this z definitely should be a negative value. So you just put a negative in front, which is negative 0.674. And you know that this value of z in your formula is equals to negative 0.674. Yeah, so from here, very easily, you can get the value of sigma. So if you try to simplify, the original fraction form should be 450 over 337. Or you can make it into decimal number, which are 3 significant figures, so 1.34. Alright, so this is how we solve question number 2. Okay, so we are now at question number 3. We are given the summary of data about the heights for adults in a certain place. Okay, so sorry. They want us to draw a histogram to represent this information. So when we want to draw histogram, the very first step is we have to always check about the width of every single classes. So for the first class, 130 to 150. So the class width is 20. Then second class, 150 to 160, the class width is 10. So we are having unequal class width. Right. So first step, let us try to list out all the class width first. Okay, so for the first class, like what I told you just now, 130 to 150, so the class width is 20. For second class, this one, okay, so the class is from 150 to 160, so the class width is 10. And so on, okay? So the third class is 10, fourth class is 5, then the sixth class is 20. So very obvious that we are having unequal width. Therefore, when we want to draw this, we are going to draw unequal width histogram. For unequal width histogram, the x-axis is the height, and the y-axis should be frequency density. So I need to find out frequency density first. Frequency density. Okay, so how to find the frequency density? So recall back the formula. Frequency density, I write it as FD. Right, so to calculate the frequency density is related to frequency and also the width one. Alright, it's proportional to the area. So frequency divided by width. to get the frequency density. Alright, so you need to find out all the frequency density also before you can draw the histogram. So take 16 for this particular class divided by the class width 20. So you're having frequency density 0.8. So apply all the same, okay, for all the classes. So for the second class, I'm having 3.2. The third class, I'm having 7.6 and so on. Alright, yeah, so after I find out the value for frequency density and also provided with a height, I can start deciding the ratio or the scale for my graph. Okay, so for the height here, I start from 130 until 195. So I have to decide a certain scale so that I can fit everything in. Alright, so what I do here is this one. I try to use the ratio. Start from 130 to 195, right? Okay, I need to enlarge it a bit. So 130, so I can make this one as 130. Then followed by 140 and so on. So it is nicely fit until 195, okay? Then don't forget to label your x-axis. They are talking about the height, so it is actually height and also HCM in cm. Alright, then after that, for the frequency density, the highest value I have for frequency density is 12.8. Then again, I need to try and put in the scale for the y-axis. Okay. Alright, so a small note to take note. For x-axis, right, in histogram, your x-axis not necessarily must start from 0. So you can start for any value that's convenient for you. Then if you want, you can just put a slash or maybe a zigzag sign here. That means that it is not starting from 0 if you want. Okay. And now for the value of y. For the value of y, scale y, the highest value is 12.8. So maybe what I can do is like I can label this as 2. I have to start from 0. Y value must be starting from 0. So 0, 2, then I'll make this as 4, 6, 8, and so on. 10, 12. Yeah, if you try to observe and see, okay, 12.8 can be nicely fit into the graph as well. Right, so this is my frequency density. Alright, then now I can start plotting all the point here and all the bar here. From 130 to 150, the height is 0.8. So for 130 to 150, 0.8, that means it should be 4 boxes. I can't see clearly, so I have to enlarge it more, yeah. Okay, so 130 to 150, 0.8. So this one is 0.8. Okay, from 150 to 160, the height is 3.2. So 3.2 is should be somewhere here. And then until 160, so this is my second bar. Okay, then for the third bar, the height should be 7.6. So you have a look for your own calculation just now, yeah? So 7.6 will be somewhere here. And then the width is 10 unit also, so I think it should be until this part. Until 170, right? Okay, so I need to make it smaller a bit. Okay, then after that, the next class is 12.8, the height 12.8. So 12.8 should be somewhere here, if I'm not mistaken. But the width is only 5 unit, yeah? So the class width is 5 units, so it should be smaller. Okay? Okay, of course my graph doesn't look so nice. So for you yourself, try to use a very nice, draw it straight, okay? Then the last one is having the width 20 unit and the frequency density is 0.3, 0.6. So it should be 3 boxes until 195. Alright, so if you finish drawing by right, your graph should look more or less something like this. Okay, Yeah, so when you are setting up the graph, right, please make sure that in your solution, you try to show the value for class width and also the frequency density. Okay, right, in your calculation, try to show all this value here in your solution. All right, so let's continue further to part B. Okay, so for part B, they are saying that the interquartile range is RCM, show that R is not greater than 1.5. Okay, so we are talking about interquartile range. Let's go back to our data given. Okay, I want to use the data given here. Interquartile range means that you need to group all your data from smallest to largest value and see where's the Q1 and Q3 located. Okay, then maybe you can try out here. All right, so to find out where's the Q1 and Q3 located, I actually need the cumulative frequency. Yeah, so I try to copy the table here so that you can see it more clearer. Okay, so this is my data, right? Okay, so before I can decide where's the interquartile range, what's the interquartile range, I need cumulative frequency. So I write as cumulative frequency here. Cumulative frequency. Okay, so cumulative frequency means that you accumulate all the frequency from bar to bar. So the first class, of course, is 16. For the second class, cumulative frequency is you take 16 plus 32. So by right, you should have 48. Okay, then after that, plus 76. 48 plus 76, you get 124. Then 124 plus 64, you have 188. And after that, plus a 12, you get 200. So this is your cumulative frequency. And then for your Q1, where is your Q1 located? So your Q1 located at, you take 200, the total frequency divided by 4, because Q1 located at the first 20%, 25%. From smallest value to the Q1, it consists of 25% of the data. So I take 200 divided by 4, therefore I get 50. Okay, so the position is 50, the value is not 50 for Q1. So I want to know where is Q1 located. So for this particular bar, it consists the value, the position from 0 until 16. Then for this bar, it consists the position from 16 until 48. Then I want to look for 51. It should be under this class. That means on this class consists the data with the position 51 until 124. Okay, so that means you can see that Q1 is in the class 160 to 170. Okay, then Q3, I want to know where is Q3 located. So the Q3 is located at, you take 200 divided by 4, you need to times 3 because it is 75%. So Q1 is 25%, but Q3 is 75%. So when you multiply, you are having 150. Then again, you need to list out also and tell them where is Q3 located. So just now for this class, right, the location value from 48 until 124 is here. So for this one is from 124 or 105 until 188. And 150 is inside this class. Therefore, I know that it is inside the 170 to 175. And when we are talking about the interquartile range, so interquartile range means Q3 minus Q1. And when they say not more than, that means at most the value is 15. So I want to look for the greatest interquartile range. So what's the greatest interquartile range? I have to take the largest value for Q3 minus the smallest value for Q1 so that I can get the interquartile range, right? So it is 15. So you can see that no matter how you calculate, right, the largest value for IQR is only up to 15 only. It will not be greater than that. Okay, yeah, so this is how we solve this question number 3. Okay, so we are now at question number 4. Right, so there's a game for 2 players. It's played using a fair 4-sided dice. They are fair 4-sided. And then with the side number 1, 2, 3, 4. One turn consists of throwing the dice repeatedly up to maximum 3. Okay, so one turn. One turn means that if you have one turn, you have to throw the fair dice maximum for 3 times. Okay, maximum, yeah. Right, so when a 4 is obtained, no further throws are made during that turn. So for this sentence, it means that, okay, if let's say for the first row, in a turn, for the first row, when you get the 4, then you will stop throwing already. Once you get the 4, then you stop throwing. But of course, if let's say the first row you didn't get a 4, then you can continue to throw for the second time. Then if let's say you didn't get the 4 again, then you can throw for the third time. If for the third time you still haven't get any 4, then you cannot also continue for the fourth time, because here they mentioned that maximum 3 times of throw, right? So this is considered as one turn. So that means one turn, you might have only one throw because you already get a 4 in the first throw. Or maybe in one turn, you will have 2 throws, which means that the first throw you didn't get a 4, but the second throw you get a 4. Okay, right, so that's the meaning for the game. So we have to analyze a bit before we can answer the question, so that you understand what is the rule for the game. So there's a player who obtains a 4 in their turn, scores 1 point. As long as you get a 4 in the turn, then you score 1 point. All right. So now they want us to show that the probability a player obtains a 4 in one turn is 37/64. Okay, so what is the probability for us to get a point? Okay, or obtain a 4. All right. So maybe we focus on obtain the 4 first. So when you are trying to throw the dice, right? Like what I told you just now, maybe for the first time, when you throw the dice, you already get the 4. And you should stop at that point, right? Because once you get the 4, you stop throwing. So if let's say you throw the dice for the first time, you get a 4, the probability will be 1/4, right? So it will be 0.25. So that's a first case where you throw the dice for the first time, you already get a 4. So after you get a 4, you just stop it there, right? So that's the first case. How about for the second case? So for the second case is, for the first row, you might not get the 4. So the probability is 0.75. To get the 4 is 0.25, right? So not getting a 4 is 0.75. Then for the second row, you get a 4. So you have 0.25 here. Okay, so this is the first case. This is the second case. First row didn't get a 4. Second row you get a 4. And after that, we also have the third case where when you throw it for the first time, you didn't get a 4. When you throw it for the second time, you also didn't get a 4. But when you throw it for the third time, you get a 4. Okay, so that's the third case that we have. How about, is it possible for me to get the next case where I throw 4 times in total? First 3 times I didn't get a 4, but the last time I get a 4. So that is not part of our answer. It is because of, in this game, they have told you that you can just throw the die repeatedly up to a maximum of 3 times. So this one is 3 times already. Okay, even if for the third time you didn't get a 4, you cannot throw it anymore, right? Okay, so this is all the probability that we have, all the cases that we have when you obtain a 4, right, in the game. Therefore, try to use calculator for your calculation. You'll be getting 37/64. Okay, all right. So this is one of the method that we can get the value. All right. So maybe some students say that, oh, I maybe can't really list out all the cases one by one. If you want it to be safe, another option is you can try to draw a tree diagram for this case. All right. But just to let you know, if you want to draw the tree diagram, maybe the diagram is slightly bigger because you're having 3 throws. All right, slightly bigger, but of course, if you want to draw, it still can draw. All right, then from the tree diagram, you can also see that obtain a 4, there are 3 different cases here, like what I show you here. Okay, right. And there's another technique or maybe another method that you can calculate the answer and get the answer, which means that if let's say you want to calculate the probability of obtain a 4, you just take 1 minus the probability that you didn't get any 4. So if you didn't get any 4, means that all the 3 throws, you also get some other number, which is 0.75 times 0.75 times 0.75. So you can do it the other way around. That means instead of finding out the probability of obtain a 4 and list out so many cases here, you can directly take 1 minus the case where you didn't get a 4 at all. Okay, right. So some other student might ask, how about if let's say I had only 2 throws and both of them I didn't get a 4? So this one shouldn't be included in our calculation as well. The reason is because they have mentioned here that when you throw the dice, right, you can only stop if you didn't get all the 4 and you already throw it for 3 times. So that means if let's say you throw 2 times, you didn't get a 4, you still have one more chance to throw it for 3rd time, right? So this case will not be included. That means it doesn't belong to our calculation or our answer. Right, so if let's say you take 1 minus 0.75 power 3, then by right you'll be also getting 37 over 64. So there are 2 options for you. Either you list out the case one by one and get the calculation, or you can just take 1 minus the probability of not getting any 4. Okay, and before you proceed to the next example, right, or maybe the next question, just want to emphasize and let you know, and to make sure that you are aware, what's the meaning for this? This is a probability of obtaining a 4, right? And in the question just now, they did mention that when you obtain a 4 in the turn, this one is 1 turn, okay, in 1 turn. For 1 turn, you can throw it for 1 time. If let's say you get a 4 in the first throw, you can get 2 throws. If let's say the first throw you didn't get a 4, second throw you get a 4, and so on. Right. So all these are 1 turn. Okay, so when you calculate this probability, basically it means that this is a probability of obtain a point. A point in 1 turn. Okay, so because in this question they have already mentioned that when you get a 4, you will score a point. All right, you will score 1 point in the turn. So this is also the probability of obtain a point in 1 turn. Okay, so what I need to emphasize on this one, because we will need to use this in the next part. Right, okay, so let's proceed to part number B. Okay, so for part number B, we have 2 persons here, Sino and Yao, play this game. So X and Y. So they want us to find the probability that both of them, okay, both of them not scoring any point in their first 2 turns. Okay, so we focus on 2 turns, yeah. Okay, so just now, the probability that we get is obtaining 1 point in 1 turn. And now, we are having basically 2 turns. Okay, so we're having basically 2 turns, and how can we calculate the probability? All right, so what does it mean? It means that if you want to calculate the probability that Zeno has no point, okay, and then at the same time, Yao also has no point. Okay, so let's think about Zeno first. So if let's say I didn't get any point, right? So that means the probability is 1 minus 37 over 64. This is for 1 turn. And then because they are saying that they both play for both turns, 2 turns, right? So for Shino, the second game also 1 minus 37 over 64. Then now it's Yao's turn. So for Yao's turn also the same. They didn't score any point on the first turn and also didn't score any point on the second turn. Okay, so if you simplify this one, of course, in short, you can just write it as 1 minus 37 over 64, then power 4 if you want. Okay, but I just try to list out everything here to let you see that this is a first term for Sino, no point. Second term for Sino, no point. First term for Yao, no point. And then the second term for Yao, no point. And of course, just use calculator to help a little bit. By right, you should have 0.0317. Right, so this is what we have for part number 2, part B, for question number 4. Okay, and let's have a look for part number C. Okay, so if you look for part C, right? So still these 2 persons, Zeno and Yao, have each 3 turns. Sorry. So each of them play 3 turns. They want us to find the probability that Zeno scores 2 more points than Yao. Okay, so X score 2 more points than Yao. So maybe we have to figure out, yeah, what are the possible cases that X score 2 points more than Y. All are 3 turns, 3 turns in total. Okay, so if let's say lah, Zeno score 3 marks for all the turns. Alright, so that means if let's say Zeno score 3 marks in 3 turns, then if let's say X score 2 more points than Yao, so that means Yao might be getting only 1 point in this case, right? So that 3 minus 1 is 2. And then after that, is there any other possible outcome? Another possible case is X score 2 points and Y score 1 point. So the difference of the marks is also 2, right? So the difference of the point is also 2. Okay, so I cannot decrease the number anymore for this one, because if you decrease it 1 more point, it becomes -1. There's no -1 here. Okay, so let's calculate the probability now. To calculate the probability for first case here, okay, so let's talk about X. So X are scoring 1 point for every single game. Every single turn. So that means if I try to list out one by one, then I will have 37 over 64. Score 1 point for the first turn. Score 1 point for the second turn. Score another 1 point for the third turn. Okay, so that means this one is you obtain a 4, or maybe you obtain 1 point. What can I write here? So maybe you here is like you got 1 point. Okay, you get 1 point, you get 1 point, you get 1 point. And then at the same time, Yao has only scored 1 point, 1 turn, okay, in 1 turn out of the 3. So if I want to calculate the probability for Yao, okay, so let's have a look like this. For first turn, assume that Yao scored, so you have 37 over 64. For first turn, let's say she or he score 1 point, so 37 over 64. For second turn, didn't score any point, so it should be 1 minus 37 over 64. Then for the third turn also, it will be 1 minus 37 over 64. Okay, so you can see that score 1 point for 1 turn, another 2 turns has no point. But if you have a look for this one, right, when I write out my solution like this, basically it means that it is first game have 1 point, second game or second turn no point, third turn also no point. But we can also have the case where first turn no point, second turn got point, third turn no point. Okay, or we can also have first 2 turn has no point and then the last one got point. So for all the probability of not getting the point and also getting the point, they are actually the same. And this is one of the case that I write out. So if you observe the solution here, there are 3 different cases. That means this is case number 1, case number 2, and also case number 3. That means you have to multiply this equation or this particular expression here by 3. So you have to multiply 3 because of 3 cases here. Okay, or some students, they are looking at it as a binomial distribution. So that means, I got 3 games, then I get a point only for 1 game out of the 3. So that means they know that this is 3C1, then P power 1, then these 2 are the cube, so Q power 2. Okay, so this is another option that you write out your solution if you treat it as a binomial distribution. Okay, and then the 3C1 here, basically if you press calculator, the value is actually a 3. Okay, so just now I multiplied 3 because of the different cases here. You can write 3C1 if you treat this as a binomial distribution. Alright, so this is the solution for my first case. So let's have a look for the second case. Okay, so for the second case here, now Zeno score 2 points out of the 3. So again, like what I told you just now, if you want, you can treat it as a binomial distribution where you have 3 games in total or 3 turns in total. Out of 2 games will score a point. So that means you're having 37 over 64 power 2, which is the P power 2, multiplied with Q power 1. Okay, so we settle for X already. Now we look at the Y. So y didn't score any point in all the 3 turns. So let's have a look. If let's say for first turn didn't score any point, this is a probability. Second one also this, also not scoring the point, so same probability. The third game is, or the third turn also the same without the point. So 1 minus 37 over 64. So you can simplify this part as 1 minus 37 over 64 power 3 if you want. So these are the possible 2 cases that we have. And to get the final answer, of course, you need to total them up. Okay, so you get the answer for the red color probability, multiply everything together. Then you multiply the answer for the blue color probability as well. Okay, then you add them together. So if you try to use calculator, right? First case, you should be having this super long value lah. Of course, you no need to write out in the exam. Okay, no need, because it won't give you any extra mark on this. But I just want to write it out so that you can double check if let's say you're not able to get the answer. It's a super long value, right? After that, I total them together and simplify it into 3 significant figures. So by right, you should have this 0.0914. Alright, yeah, so this is how we solve this question number 4. Alright, so question number 5. In a certain area in the Arctic, the probability that it snow on any given day is 0.7, independent of all the other days. They want us to find the probability that in a week, it snows on at least 5 days. Okay, so you can see from here, you are having a total of 7 days, and they want to find out the probability for snowing for at least 5 days. So if you have a look for the structure of this question, right, it is something like you're having a bigger number, which is 7 days, and then out of these 7 days, right, at least 5 days, that means a certain number of the days, something happened to these days. So this kind of structure belongs to binomial distribution. So like what I told you often in a lot of other videos, basically for binomial distribution, it's quite hard for us to identify clearly. There's no keyword. So you have to look at the structure of the question, right? So the structure is always like this. Okay. So from here, I know that x is binomial distributed with the n equals to 7. And what's the probability for snowing in 1 day? So it is 0.7 given in the question. So my p is actually 0.7. All right. And then just to recall back a little bit, if let's say you're having binomial distribution, to find out the probability for x equals to r, what's the general formula? So you have to use NCR, p power r, then q power n minus r. Okay, so this is a general formula for binomial distribution. Then let's have a look for the question here. They want us to find the probability that x is greater or equals to 5, at least. So at least means included the 5 and more than that. So it will be x greater equals to 5. So 5 is included and the number must be greater than 5. So that means I can start with 5 first. So when x equals to 5, the formula is 7c5 p power r. So p power 5, q power n minus r means 0.3 power 2. So that's for x equals to 5. The next one will be x equals to 6. So 7c6 and so on. Then x equals to 7. So it will be 7c7. Okay, can I have x equals to 8? Definitely cannot, right? If you try to press a calculator, it will be a mass error. Or by common sense, you know that in total I had only 7 days. So how is it possible for me to have 8 days knowing? So impossible, right? Okay. All right. So now after you write out the steps slowly like this in the general binomial formula form, then only you try to press the calculator and get the final answer. Okay. So by right, you will be getting this answer, which is also a long one. You don't need to show this in exam. You can directly cut it short into 3 significant figures. Okay, so this is what we have for part 5A. And next, let's continue to 5B. Okay, so now they are talking about a week already. Just now we are talking about the days that snow, right? So now we are talking about a week, yeah? So there's a week, when a week snow at least 5 days out of 7 is called a white week. Okay, then now you are having 3 weeks in total. They want to find the probability that at least one is the week, one is the white week. So again, you can see the structure from here. 3 weeks, and you are interested to find the probability for at least 1 week something happened. So it is still a binomial distribution, but different from what we have in part A. Part A is they are talking about the number of days. If you can have a look one more time, they are talking about at least 5 days. And now they are talking about at least 1 week. Therefore, if you want to differentiate them clearly, you can use another random variable, which is the y. And we are talking about this y as a number of weeks. Okay, so y is also binomial distributed. I have 3 weeks in total, which is the n. And then what is the probability for snows? At least 5 days. So if you want to put in the probability for snow at least 5 days in a week, you have to go back to your part A. This is the probability that snow at least 5 days in a week. This is the probability. So this P, now I want to put it inside this part. Okay. And because I want to use this value to calculate the final answer, right? Therefore, I will strongly suggest you to keep your answer as long as possible in your calculation to get the most accurate answer. Okay, so some students might say that, oh, I just want to cut it short into 0.6647. So if you cut it short, throughout the calculation, you might lose some accuracy, and then you might sometimes find out that your final answer is slightly different from the marking scheme. All right, so we will strongly suggest students that if can, you try to always keep the value as long as possible in your calculation. Okay, so let's have a look for part number B. They want you to find the probability for y greater equals to 1. At least one white week, so y greater equals to 1. So y greater equals to 1 means you can start from y equals to 1, y equals to 2, y equals to 3, which is too long for me. So if I feel lazy, I want to get it shorter, I can just take 1 minus y equals to 0. So what is the probability for y equals to 0? So 3C0 NCR. Okay, then P. This is the P. Power 0. And then Q. Power 3. Okay, so from here, I'll be getting this. Also a long value. Then after that, only I cut it short into 3 significant figure. And by right, you should have this value as final answer. Okay, so this is what we have for part B. So again, for A and B, both of them are binomial distribution. And please make sure that you learn up this technique, okay, to identify the binomial question. Okay, then let's proceed to part number C for question number 5. Okay, so that's talking about another area in the country or in the place, yeah. The probability that a week is a white week is 0.8. So they are still talking about the week. So use a suitable approximation, highlight the keyword approximation. For AS stats 1, right, we have only one kind of approximation, which is from binomial to normal. So you see this keyword, I think is very obvious already, right? So start from binomial and you want to change it become normal. To find the probability that 60 weeks you have, then fewer than 47 are white weeks. So fewer than 47, something happened. So again, very obvious, it is still about number of weeks. So I still using the y. So for this question, my y is having 60 weeks in total. And then the probability of white week is 0.8. It is given in the question. Okay, then since the question already hint you very clearly that we have to use approximation, so we have to change it become n. But of course, if you're interested, right, you can still double check the condition. So there are 3 conditions here that you can check. The first one is n greater equals to 30, must be large. The second one is you have to check your value for NP. NP should be greater than 5, and the third one should be NQ greater than 5. All right, but of course, they really ask you to apply approximation. So definitely, this question already fulfill all the three conditions here. All right, so let's continue. For the normal distribution, right, the first value in normal distribution or parameter in normal distribution is the mean. How can I get the mean from binomial? So to get the mean, you have to take n times p. So n is 60, p is 0.8, therefore you get 48. Then how to get the variance? The variance will be np cubed. So np cubed will be n 60 times p 0.8 times q 0.2. So by right, you will be having 9.6. Okay, so just a small reminder here. If you want to get the mean, it should be n times p. Then if you want to get the variance, it will be np cubed. Okay, so what's the value for n? This one. And what's the value for p? This one. Yeah. Right, then after that, you have to start the calculation for probability. So why? They said fewer than 47, fewer, not include the 47, so there's no equal sign. 47 here. Okay, so this is binomial distribution. Originally, binomial distribution is discrete random variable, and we want to change it become continuous random variable, which is normal distribution. From discrete to continuous, there are some gap. Okay, for discrete there's gap, but continuous has no gap. Therefore, continuity correction is needed. So to apply for continuity correction, in this case, it should be y, okay, then smaller than 46.5. I have to minus 0.5. Okay, in some other cases, you might need to add 0.5. So for those who want to know the details, how to decide whether is it minus 0.5 or positive 0.5, please have a search for the lecture videos in the channel, right? Okay, so now I have applied continuity correction in this case, okay, in this step. So after that, I have to standardize it become Z. Why? Because this is normal distribution. To calculate the probability, you have to use the normal table. So it is a must for you to rationalize it first. So how should I rationalize the value of Z? So you take Z, the x value minus the mean, which is minus 48, divided by standard deviation, square root 9.6. Okay, then after that, use the calculator to help you a little bit. So your answer, your value for the Z should be 0.484 negative. Okay, so a small reminder here, because due to the accuracy for the normal table, our normal table here, our Z value can be shown until 3 decimal place. Therefore, when you want to calculate the value for Z in this place, please keep it to 3 decimal place as well. All right, so just a reminder, 3 decimal place. All right, and after that, for Z smaller than negative 0.484, the particular area that we want to find is actually this one. This area. This is negative 0.484. Negative. In the normal distribution table, you realize that all the value of Z must be positive, cannot be negative. You can see that there's no negative sign here. Therefore, we have to think a way how to replace this area by the same one for positive value. So if you try to draw a similar area, it should be on the right hand side. And it becomes 0.484, and this is the area that you want to find. Okay, so these two areas are the same because they are symmetrical. Okay, then after that, only you can start the calculation. So now I'm having the positive Z already, but in our table, they always provide us with the smaller, with the smaller than area. Like when you look for 0.484, they are looking for smaller than 0.484. And for my question here, I want to get greater than 0.484, right? So you have to take 1 minus the value of 0.484 from the question. So let's go to the table now. 0.4. This is your 0.4, 8, and 4. So if you try to read the value from here, you will be getting this 6844, and then you have to add 14 at the last two digit. Okay, so when I try to total this number, I will be having this, say 6858. So go back to our solution here. I have to minus 0.6858, and you should get 0.3142. Or you can make it become 3 significant figure, which is 0.314. Okay, yeah, so basically this is how we solve the question number 5. Okay, so we are now at question number 6. Okay, then for this question, Harry has 3 coins. So coin 1 is biased, so that the probability of obtaining a head is this one, 1/3. Coin 2 is also biased, so the probability is 1/4 to get a head. Then the third coin is also biased, so to get a head it is probability 1.5, 1/5. Harry throws the 3 coins. The random variable x is the number of hits that he obtains. So draw up a probability distribution for x. Okay, so for this one, there are many ways for you to get the answer. Some students might want to draw number line if you want. Okay, then for me, what I do is I just try to simplify some possible cases here. Okay, so what am I going to do is I will separate into C1, coin number 1, coin number 2, coin number 3, then the X. Okay, and also the probability. All right, so again, all the steps here are just a suggestion. So to me, I feels like I don't wish to draw a tree diagram which is so big when you want to throw the 3 coins. Okay, all the outcome are very, very big. So I try to avoid that if can. But of course, some students, they prefer to use tree diagram. You can just go ahead. All right, so now let's start with the first case first. Okay, so they throw the coin, right? So the coin might give you only either one of the result, which is tail or head. So we start from the first case. If I throw the coins, three coins, and all the coins I get the tail, that means tail, tail, tail. Okay, if I get tail, tail, tail for all the 3 coins, what is the x here? So they said x is the number of head. So if you have a look for this case, that means you have no head, all the tail, so x is equal to 0 for this case. How can I get the probability? So for the first coin, to get the head, it should be the opposite of this one, right? 1 minus 1/3, and therefore you get 2/3. For the second coin, if you didn't get a head but you get a tail, so the probability should be 1 minus this, so it should be 3/4. Same thing happened for the third case, so you are having 1 minus 1/5, which is 4/5. Okay, so if you try to get the probability, it should be 2/5. So we have done for the first case here. That means when x equals to 0, or when you throw the coins, or the coins show you a tail. Okay, then now let's proceed to the second case. So for the second case, right, maybe for the first coin I got one head, I got a head. Second and the third coin I get a tail. Okay, so for this one, if you simplify it, right, by right your x should be a 1 head, 2 tail, so number of head is equals to 1. Okay, so if you observe from here, right, I might have some other cases where first coin is tail, second coin is head, followed by third coin is also tail. This will also give you the result where x equals to 1. Then I want to list out the last case here also. If I have DDH, only the third coin show the head, I also have x equals to 1. All the 3 cases here contribute to x equals to 1. Okay, then now again, let us calculate the probability very slowly. Okay, so for the first coin now, they say first coin is a head, so it should be 1/3. Second coin is a tail, so you should take 1 minus this, so you're having 3/4. Same thing happened for the third coin, also tail, so 1 minus 1/5, so you get 4/5. First case. Second case, tail, head, tail. So tail is 1 minus this, you get 2/3. Head is the probability given 1/4, and another tail is 4/5. Okay, then after that, the third case. So for the third case, basically you should have tail, tail, head. So for tail, you can refer back to all this part here, yeah? So 1 minus 1/3 is this, 2/3. 1 minus 1/4, you get 3/4. And the last one is a head, so it should be 1/5. Okay, so try to calculate all the probability here, and you try to figure out what's the total for these cases. So you calculate the probability for first case, calculate the probability for second case, calculate the probability for the third case, and then you add 3 of them together. So if you try to add them together without any careless mistake, by right, the answer that you should have is 13 over 30. Okay, so all these are the probability of x equals to 1. Okay, then next one, we proceed to x equals to 2. For x equals to 2, I can have head, head, that means 2 head with 1 tail. So this is x equals to 2. Another case is head, tail, head, also x equals to 2, then tail, head, head. So all these cases contribute x equals to 2. Okay, yeah, then you just try to calculate the probability again. Head, head, tail, so 1 over 3, 1 over 4, then 4 over 5. And the same thing happened for the other cases. 1 over 3, then 3 over 4, 1 over 5. Then 2 over 3, 1 over 4, and also 1 over 5. Again, try to simplify all the answers here and also add them together for all the 3 cases. So by right, your total should be 3 over 20. Okay, then after that, you can still continue with the last possible case here, where if you throw the coin, all the coins, right, you are so lucky and you get all the head. So this contribute to x equals to 3. So what's the probability here? 1 over 3, 1 over 4, and also 1 over 5. Okay, then calculate the probability. It should be 1 over 60. Alright, so after I consider all the cases here, okay, for the 3 coins, then I have to rephrase my answer into a probability distribution table. So the probability distribution table will look something like this. Okay, so the first row we put in the value for x, the second row we put in the value for the p. So I'm having x equals to 1, x equals to 0 first, yeah. X equals to 0, then x equals to 1, x equals to 2, and also x equals to 3. Okay, then from that, you put in the probability here, so 2 over 5, 13 over 30, 3 over 20, and also 1 over 60. Alright, and usually to have a final check for the answer, right? Usually I prefer to double check. Okay, so I will usually try to do this step, simple check. I take all the probability here and add them together. So if you get equals to 1, that means very likely your answer is correct. Very likely, not 100%. But of course, if let's say your answer is not equals to 1, when you add all the probability together, definitely your answer is wrong. Okay, so better we can double check before we finalize the answer. Alright, so this is how we get the part A answer for this is a probability distribution table for the x. Okay, and please take note, you are not allowed to just show out this as final answer. Okay, because the marks to get the probability will be given as well in all the question here as method mark. Right? Okay, so let's proceed to part B. Okay, then now Harry has 2 other coins, the other 2, each of which is biased that the probability of obtaining a head is P. So these 2 coins now is slightly different. So these 2 coins now, to get a head, the probability is P. Just now one is 1 over 3, 1 over 4, and also 1 over 5. Okay. Alright, so he throws all the 5 coins at the same time. The random variable y means the number of hits that he obtains. So now he throws 5 coins. Now, y is the number of hits now. And they give us a very important information. Y equals to 0 equals to 6 times of y equals to 5. And they want you to find the value for p. Okay, so let's start from the information here. They tell us that y equals to 0 equals to 6 p, y equals to 5. Okay, so y equals to 0 means what? Means that 0 hits obtained in 5 coins. So that's meaning for y equals to 0 hits obtained in 5 coins, in throwing 5 coins. So if let's say all the 5 coins are not showing head. That means all of them are showing tail. If all of them are showing tail, for the first coin, the tail probability is 3 over 2. 2 over 3. For second coin, the probability of getting a tail is 3 over 4. And the third coin will be 4 over 5. And don't forget that we still have a fourth and a fifth coin, right? Both of them are the same, which is P multiplied with the P. It shouldn't be P, right? Head is the P ma. So here, that means I didn't get a head. It should be 1 minus P multiplied with 1 minus P lah. Okay, so to make it easier, I directly put it as a square. That equals to 6, so you just copy a 6. Y equals to 5. What's the meaning for this y equals to 5? That means the 5 heads obtained in 5 coins. So that means all the coins that you throw, you get all the head. Okay, then again, the same thing happens. First coin, to get a head is 1 over 3. Second coin, to get the head is 1 over 4. Third coin is 1 over 5. Then for the new 2 cases here, 2 coins here will be P times P, which is P squared. Okay, so for this particular question, what you need to do is that you just try to simplify the equation and solve them. That's it. Then you will get the P directly. Okay, so allow me to skip a few steps here. You try to expand and simplify it. By right, you will get this quadratic equation. 3p squared minus 8p plus 4 equals to 0. And after that, you can further simplify it or factorize it. So by right, this is negative 2, this is negative 2. Then I get a 0 here. So p is equals to 2 over 3. Another one is p equals to 2. And we have to ignore this answer, p equals to 2. The reason is because a probability cannot be more than 1. So the correct answer for the probability is 2 over 3 for this case. Right, yeah, so this is how we solve the question number 6. Okay, so the last question for this paper, I have 8 digits here, and then there are 1, 2, 3, 4, 5, 4, 5. So I have 2 identical 2 and also 3 identical 4. How many different arrangements are there of these 8 digits? So please highlight the keyword arrangement. So basically they are talking about permutation with the keyword arrangement. So in your step, usually you can see like something like factorial or maybe NPR, something like that. Okay, so to arrange the 8 digits here, I will have 8 factorial. But because out of these 8 digits, right, I'm having some identical number where I'm having 2, 2, so you have to divide it by 2. I have 3, 4, so you have to divide by 3 factorial. Okay, so this is what we get, 3360. Simple and straightforward. Okay, so let's look for part B. For part B, they want to find the number of different arrangement again. You can see here, different arrangement of the 8 digits where 2 is at the beginning, another 2 is at the end, then the 4s are not all together. Okay, so let's say I fix the 2 here, cannot move anymore, and also I fix the 2 here that is cannot move anymore. So in between, I still have 6 numbers to arrange. Okay, so I need to consider only the arrangement for these 6 numbers here. So out of these 6 numbers, right, I'm having 1, 3, 5, 4, 4, 4. So I just want to consider the arrangement for these 6 numbers. But they are telling us that all the 4s are not all together. So what's the meaning for not all together? That means the meaning is the opposite of all together. That means you close the not first. If you try to close the word not, so you can see that all the 3 4s are together, right? Are all together. That means they are always together. But if you put in the word not, that means you have to take the total minus all together one. Okay, so to arrange the number here, what am I going to do now is I try to group all the letter 4 together. So I treat as one unit. So you're having 1, 2, 3, 4. 4 items here. Okay, so 4 factorial. So this 4 factorial is actually all the 4s are together. And like what I told you just now, right? If you want to get the probability for not all together, you have to take total minus all together. So this is all together. So I need my total to minus the all together. What's my total here? So the total arrangement is, you consider the 6 number here. So you're having 6 numbers, 1, 2, 3, 4, 5, 6. So arrange 6 numbers or 6 items, it should be 6 factorial. But again, when you are arranging the 6 numbers here, right, there are 3 identical 4. So you have to divide it by 3 factorial. So this is a total minus all the 4 together. And this is how you get the probability of not all together. Okay, so by right, you'll be having 96. So this is how we solve part B. And let's have a look for part C. Okay, so for part C, actually it is a little bit confusing. Not to say confusing, but complicated. But it's very interesting. Okay, so let's have a look for part C. Yeah? So there are 3 digits are selected at random. Highlight the keyword selected. So selected means that combination. Alright, so every time when we deal with combination, you have to be very, very careful. Right? Okay, so again, the same digits here are 8 digits. So they say find the probability that all the 3 digits are different. All 3 are different. Okay? Alright, so like what I mentioned just now, why when we deal with the combination question, we must be very, very careful. So one of the reasons is because when you are having the identical letters or identical items, right, under the combination, you might need to consider it case by case so that you won't mix up all the cases and whatsoever, right? Okay, so you have to separate it into different cases, especially all the identical letters or all the identical items. Okay, so that you won't get confused or select repeatedly or whatsoever. Okay, so because of this reason, therefore I will list out, okay, all the numbers here because I'm having one group of 2. There are two, right? So I maybe put one group as a 2. Okay, then I have another 3 letters 4, 3 numbers 4, so I put it as a 4 here. And then as the last 3, the other number 1, 3, and 5, each of them is only 1, 1, 1. So I just group all the 1, 3, and 5, all these different number as one group. So I'm having 3 groups in total. Okay, so I have to do it in this way because we are having identical number. So when we have identical number in combination question, it will be strongly suggest you to separate them into different groups. Like this one, I separate 2 and 4 into each group, 2 groups. And then the rest of the number has only 1 time 1. Then I just directly put all of them in a group. Okay, so now we have to try to use some common sense here, okay, to set up the cases. First case, they said they want to have all the digits are different. If I want to have all the digits are different, right, that means I don't select any number from 2 or 4. I just directly get all the 3 from this group. Okay, all right. So this is the first case. So if I get 1, 3, 5 from this group, so directly all the 3 digits are different. How to calculate the probability? So let's have a look here. For this group, you're having 3 numbers in total. You want to choose all of them, which is 3. So 3 numbers, you want to choose 3. This is the number of combination. And you have to divide it by the total combination. So total combination means that you are having 8 numbers and you want to choose 3 of them. So it should be 8C3. All right. So use calculator to help a little bit. You'll get 1 over 56. So this is the first case that I have. All the 3 numbers are different. So 1, 3, 5, you select all are different. Okay. So one more case is you might get 1 letter 2, no 4, and 2 numbers from 1, 3, 5 group. So if this is the case, right? Okay, so first group, You have 2, 2, you want to choose 1. So it should be 2C1. Haven't complete yet. You have to consider also the third group. So for this 3 number, you choose 2. So 3C2. So 2C1 times 3C2. Again, divide by the total combination 8C3. Because A number, you want to choose 3 of them. Then if you use calculator again, your answer for this case should be 3 over 28. Alright, so maybe now it's your turn. You can try to think about what is the possible case again for this one. So maybe now you didn't get any 2, you get a 4 and also 2 from the group 1, 3, 5. So same thing happened here. For the 4, originally you're having 3 of them. So 3, choose 1 number. 3 number for 1, 3, 5, and you want to choose 2 of them. So 3C2 divided by the total combination is C3. So you should be having this 9 over 56. Okay, then double check again, and lastly, we actually have one more case here. Okay, so the last case will be I get 1, 2, 1, 4, and also 1 from the group 1, 3, 5. So calculate the probability. 2, 2, you choose 1. 3, 4, you choose also 1. Then 3, 1, 3, 5, you choose also 1. Then divided by AC3 again. So from here, you'll be having 9 over 28. Okay, then after that, if I want to get the total probability, of course, I have to add them together. 1 over 56, then 3 over 28, and so on. Okay, so end up, you should be having 17 over 28. Okay, all right, so this is how we get the answer for part C. And I understand that for some students who look for the marking scheme, right, actually in the marking scheme, they show quite a lot of steps. Right, so to me, I think this one is a more direct, more straightforward one. If let's say you don't like this technique, another easier method that you can try to consider is you take the total, okay, you take the total minus all the cases with 2, 2 or 4, 4 or 4, 4, 4, something like that. But to me, I think that way you have to consider more, right? So this is more straightforward. The method I show you here is actually more straightforward. So if you are interested to get the other technique or other method, yeah, you can refer to marking scheme. Right? Yeah, so this is what we have for the question 7C, and it is the last question for this paper already. All right, so we end the video here. Thank you very much for watching the video.